I've installed a small feed pump for my boiler that I got from eBay. It is run. It's run from an eccentric on the engine. You can see that it has about an 1/8 inch stroke. The feed pump runs through my hand pump, down through a little tube, into the feed pump, up to a T where there is a bypass valve, currently off when it's up. If the bypass valve is off or shut, then the pump pumps directly into the boiler. There's a check valve preventing backflow out of the boiler, and when the bypass valve is down, that is in this position, then I get flow through the bypass back down through another little tube back into my water reservoir. There's a resistive sensor installed on the side of the boiler that measures, it's insulated from the boiler, has a little contact that goes into the water. When the water comes in contact, it shorts the sensor to the body of the boiler, so I get a variable resistance to ground through the sensor. That sensor wire and a ground wire to the boiler comes back to a prototyping board, which contains a Parallax BasicStamp microcontroller. The BasicStamp microcontroller is controlled with a piece of software that you can write code for, and also I get a display from the code of resistance units. Values below 250 for this code represent low resistance, relatively higher water level, and values above 250 represent high resistance, water levels below the sensor, low water levels. The switching point is set to 250 in this case. The boiler is now at about 475 units of resistance. If I increase the water pressure, that number should go down, and the red light should turn green. So I'm going to do that. To do that, I first have to turn the feed pump bypass valve off, and now I will pump water up in the boiler with my hand pump. You can see that we're getting close because the number is now decreased to about 270. If I pump a little more, you'll see it goes down to 200. At 250, it went from the red light to the green light, signaling that I can now turn on the boiler bypass. You'll notice that there's a servo connected to my breadboard, and it's now flat. That is a signal to me that the bypass valve can be turned into the flat position. I'm going to use the servo to operate the valve, but right now I'm doing that by hand. I'm now going to turn the steam engine on by moving the throttle valve. Now the boiler bypass is on, so the boiler feed pump, which is located right down here, is in fact bypassing back into the water tank. So you can see the water pumping out. It's not going into the boiler, it's being bypassed. While we were looking there, the light went from green to red, signaling, and the servo valve position is now up, telling me that I need to turn the bypass off. So now there's no water coming out of the bypass, it's going into the boiler. The light just went green. The light is now green, telling me that I can turn the bypass on. Now we'll run for a little bit. We can monitor what the resistance is by looking at the sensor signal, which is now 40, which means we've got a pretty good short across the sensor. As water is used up out of the boiler, that sensor will go from a very low value to a value up above 250, signaling it's time to turn the boiler feed water back on.